I have some, like, some more trig stuff with, like, angle, sine of angle A over side A, stuff like that.
The law of sines and the law of cosines, okay?
Yes.
All right. What specific problems?
And I have some trig identity stuff too.
Okay.
Alright, so the first one is prove the identity that cosine equals, or cosine of 90 degrees minus x equals sine x.
Okay. There are cofunction relationships. Sine, cosine, tangent, cotangent, and secant, cosecant. These are the cosine, or these are the cofunction relationships.
Yeah.
Each one of these is exactly the same.
Okay.
And vice versa. In other words, cosine is also equal to sine of 90 minus x. So for every cofunction relationship, you have that. So clearly the cosine of 90 minus x I can replace with the sine of x.
Yeah.
All right.
Alright, so the next one is, hold on, a field is triangular in shape with side lengths 83, 120, and 165. To the nearest tenth of a degree, what is the measure of the angle formed by the sides, measuring 120 and 165?
All right. I don't know if it was because my dog barking or what, but I didn't really get that. What's the first part of that? You said a cube or a triangle?
It's a triangle.
So we have a solid triangle that, what are these three measurements equal to?
Those are the side lengths.
No.
And then
Let's see if I can draw. We're talking about a triangle like this. I'm not sure. What kind of solid triangle are we talking about?
no, it's a field with a triangular shape with sides 83, 120, and 165. So it's just a triangle.
Okay. Okay.
And then we're supposed to find the angle that is formed by the sides that are 120 and 165.
So this angle right here?
Yeah.
Okay. Let's talk about the law of sines and the law of cosines. The law of sines says that within any triangle, this is true. The relationship of the sine of an angle and its opposite side is the same ratio with any triangle. In other words, if I look at this triangle here, the sine of A with relationship to 120, its opposite side, has to equal the sine of B with relationship to 165, has to equal the sine of C opposite 83. Okay, so that's the law of sines. And the law of sines doesn't help us here because we don't know any angle. In order to use the law of sines, you have to have an angle opposite side relationship.
Yeah.
There are two situations where you have to use the law of cosines instead of the law of sines. This is one of them, where we don't have an angle and its opposite side relationship. So I can say three different things about this triangle. If I call that side A, and this side C, and this side B, then I can say that A squared equals B squared plus C squared minus 2BC cosine of A. This is the law of cosines. Actually three of them. I can also say B squared equals A squared plus C squared minus 2AC cosine of B. You see the pattern?
Yeah.
That's the law of cosines, and it's used in two situations. This is one of them where I have three sides of a triangle. The other would be if I only have two sides of a triangle and that. In other words, if I know the angle between two sides, well then clearly I do not know this opposite side, so I can't use the law of sines immediately in that situation to solve that triangle. So these two situations are the two situations where you have to use the law of cosines. Learn to recognize it. This one is side, angle, side, and this is side, side, side from your geometry days.
Yeah.
Okay, well, in this one, I'm going to use this formula. I could use any of the three formulas because I know all three sides, but I'm going to use that as A. So I'm going to say 120 squared equals 83 squared plus 165 squared minus 2 times 83 times 165 times the cosine of angle A, the angle opposite side A. Well, notice what we have here. We have only one variable missing. In other words, we know this, that's a number, that's a number, that's a number. The only thing we're missing is cosine of A.
Well, I did it differently.
Okay, how'd you do it?
And, well, I switched the 83 and the 120.
You can choose any side you want.
Well, that would just give you the angle directly, right?
It gives you the angle opposite that side. In other words, this side here always has to be this angle.
Yeah, but if you use 83, then it's the angle in between 120 and 165 of it, which the question is asking.
Okay. I see what you're saying. All right.
Yeah.
Let's do that. Okay. So you're right. 83 squared equals 120 squared plus 165 squared minus 2 times 120 times 165 times the cosine of C. And you're right. That's what they asked for, was the angle C.
Yeah.
So let's do this. Do you have a calculator?
Yeah.
What's 83 squared?
6,889.
120 squared is
14,400.
what's 165 squared?
27,225.
Minus, what's 2 times 120 times 165?
39,600.
We still only have one unknown variable right there.
Yeah.
Okay, what's the next step here? Well, let's add these two and subtract that number from both sides. What do you get when you add 27,000 to 144,000? In other words, combine those two numbers and then subtract it from both sides. What do you get on the left?
24,625, and then...
Doesn't sound right.
No, that was just 1,400 plus, or whatever, minus. So it's 23,476. 23,000, or, wait.
Must be 33,000.
I did too many. Hold on.
What are these two numbers here? This is like 41,625, right?
Yeah.
Now subtract 6,889 minus 41,625.
We get 6,889. Negative 34,736.
36?
Yeah.
Okay. So that's now equal to what's left. Minus 39,600 cosine of C. With me?
Yeah.
Next step?
Divide by 39,600.
What's that ratio right there?
Hold on. So it's negative 0.877.
Positive or negative?
Negative. Because it was...
We're dividing?
Oh, divided.
We're dividing a negative by a negative, so this is positive.
Yeah.
And it needs to be always positive. You never want this to be negative.
Yeah.
Why? Because the cosine of C has to be some angle between 0 and 90 degrees. It can't be over 90. Because cosine of angles over 90 are negative. So this always has to be positive. So what's angle C equal to? How do you determine what angle C is?
Inverse cosine.
Okay, of this number, what is that?
It is 28.6 degrees.
All right. Once you've solved for one angle, and that's always the first step in solving a side-side-side triangle, is to solve for one angle. Now, you can use the law of sines. And that's what you have to do. In other words, wherever you use the law of cosines, you always end up using the law of sines to finish the problem. So you use the law of sines on virtually every single situation, but only certain situations do you have to start out with the law of cosines. So now that I have this angle, and I know its opposite side, what can I say? In other words, I still need to solve for angle A and angle B.
Yeah. So you can do, I'll start with angle A, so it's sine of A over 120 equals sine of 28.6 degrees over 83.
Right. And is all we have is a bunch of numbers here except for that. So if I don't want to cross multiply here. So all I want to do is multiply both sides by 120.
Yeah.
So now I have the sine of A equals that number. What do you get for the sine of A?
The sine of A equals 0.69.
And then what do you get for angle A?
It equals 43.7 degrees.
Now, we've solved for 5 of the 6 parts of a triangle. We got all 3 sides, we got 2 angles. What's the best way to get this final angle?
Add them together. And
there's no reason to do it hard, which would be using the law of sines to get it. We could use the law of sines to get it, but it's much easier to just figure out what the sum of those are, which looks to be 72.3, which means 107.7 has to be this angle here. And there's the full solution of that triangle.
Yeah.
And you started with angle C, but in reality you can start with any of the 3 sides and 3 angles. Whenever you have just 3 sides of a triangle, you can choose any angle you want to start.
Yeah.
Or any side you want, but actually you're solving for an angle. But like you said, in this problem, they specifically didn't ask you to solve the triangle, they asked you to solve for that angle, so clearly you wanted to use the definition for law of cosines that had sine of C in it.
Yeah.
All right. What else you got?
Next one is find the area of the field in number 9. So, like, find the area of that triangle.
All right, let's see. What was it again? 120?
120, 165, and 83.
Okay. Now, you've been taught the area of a triangle being what?
Well,
I mean, I know the area of a triangle is 1/2 the base times the height, but that doesn't work here because we don't know this vertical height.
yeah, so is it the,
There's a trig formula for the area of a triangle. What is it?
yeah, is it the A equals square root of, or no, S?
There's actually a bunch of them.
There's
This
three.
is the Heron's formula is the one you're talking about.
Yeah.
And that's fine to use. What is Heron's formula?
It's S times S minus A, S minus B, S minus C. All the square root of.
Hold on one second. I want to make sure I get it perfect. This is not one I come across that often. And in fact, this guy's name is spelled Heron or Hero. This is called Heron's formula or Hero's formula.
Yeah.
And it's the area of a triangle if you have all three sides.
Yeah.
Okay, and S is half of the perimeter. So what's the perimeter here? What's S equal to?
S equals, let's see, 184.
So our area would be the square root of 184 times, well, S minus one side. Well, if I take that side, I got 64. If I take this side here, I got 19. No, excuse, yeah, 19. And if I take the third side, I got 101. So it's the square root of the product of those three, where S is equal to 1/2 of A plus B plus C. So whatever that number is, stick that into your calculator, and what's the square root of that?
4,753.
Is that the number, or is that the square root?
That's the square root.
Okay. Now let's ballpark that. Let's make sure that we're in the proper region. In other words, are we off by a factor of 10 or not? Well, I know that the area of a triangle is 1/2 base times height, and I know the base is 120, and I can guess the height. Let's guess the height of 100. Well, 50 times 120 is 6,000, so we are in the ballpark.
Yeah.
And that's kind of the way I do my ballpark tests. In other words, especially when you're using a strange formula, like Heron's formula, it's easy to get off by a substantial amount. You can be off by a factor of 10 if you don't do it right. And so you always want to apply your ballpark test. Well, I can approximate the area of this triangle. I mean, I know this vertical line it's probably less than 83. In fact, it probably is. It looks to me like maybe 60. And so I can approximate the magnitude, the order of magnitude of the area of this triangle, and it agrees with my answer. So I would say yes. I would be willing to turn that in on a test as the answer to this.
Yeah.
All right. Do you have any other questions relative to this problem?
No.
All right, let's go to the next problem then. What else you got?
This one solves a triangle, and its angle B equals 35 degrees. Side A is 43 degrees, and side C is, side A is 43, and then side C is 19.
This is angle B. Call that A, and that's C. So this is 43. This is 19. What do I have to use to solve this triangle?
Cosine.
Yeah, I can't start off using law of sines because I do not have that relationship I'm looking for, which is an opposite side over its angle. So
Yeah.
I can't use law of sines initially. I'm going to have to use law of sines as the second step. But I can't use law of sines as the first step. I have to use law of cosines. I'll call that side little b. What's the first thing I want to write?
C squared equals 43 squared plus 19 squared minus 243.
Cosine of?
Cosine of 35.
Notice that on the right side of this equation, the only thing we have are numbers.
Yeah.
So b is the square root of this. Let's come up with a number for that.
$871.5.
Does that make sense?
Oh, that's the item square root of it,
Okay.
right?
But, in other words, if you see where I'm going here, this points out that you've made a mistake. Because it's impossible for that side to be 871. We need this side to be the smallest side of this triangle because it's opposite the smallest angle. So there's the ballpark test that failed. And it failed very simply. You made a small mistake. Now what's the square root of that number?
29.5.
That answer makes a lot more sense.
Yeah.
Doesn't have to be necessarily the smallest side because angle C could be smaller than 35 degrees. Okay, but it's definitely got to be smaller than 43. All right, so now how do we finish solving this triangle? What's the next thing you want to solve for?
The angle A.
Let's write that in the upper left.
So it's going to be sine A.
The reason I do that is because we want the next unknown to be in the numerator. It makes it easier to solve.
Yeah.
Okay, so what's the rest of this equation?
Sine A over 43 equals sine 35 over 29.
Okay, we just need to multiply both sides by 43. What's the sine of A equal to?
That equals 0.836.
Okay, now before we go any further, if the sine of this angle is a number greater than 1 or less than -1, then it's an impossible triangle.
Yeah.
And that's how you tell. It's only when you get to this step right there that you can tell whether it's a possible or an impossible triangle. So what is angle A equal to?
56.7 degrees.
So this is 56.7. How do we solve for angle C?
Add that to 35 and subtract that from
Okay, what's that?
180.
Looks like about 91.7, which means this has got to be 88.3. Now, what's wrong with this picture?
Is it?
I don't have the opposite side equal to the largest angle. So I must have made a mistake somewhere. In other words, angle C would need to be the smallest angle in this triangle. It's opposite the smallest side.
Yeah.
So where did I make my mistake? Let's go back a little bit. We calculated A. We were trying to calculate C. So we got the sine of C over 19 is equal to the sine of 35 over 29.5. Let's come up with angle C again, or let's come up with the sine of C. It's equal to that.
0.36.
And now take the inverse sine of 0.36.
21.
All right, now we're talking. That looks like a better answer. Right?
Yeah.
Now what's angle A?
A would be
56, 124.
123. Yeah.
Tell you what, if there's something you want to be good at with geometry or trigonometry, it's being able to subtract a number from 180.
Yeah.
Because you have to do it so many times. In other words, we're always subtracting numbers from 180 in geometry or trig. Okay, now does this picture look okay? It passes the first smell test. In other words, I've got the smallest angle opposite the smallest side. I've got the biggest angle opposite the biggest side. So from that perspective, I'm going to go with this answer. In other words, usually any gross errors that we've made will fail the initial test. That the largest side has to be largest opposite the largest angle and the smallest opposite the smallest. So since this passes it, I'm going to go with it. And notice it's not a linear relationship. This 124 degree angle is about 3 times that. But this side of 19 is not 3 times 21. So it's not linear. In other words, you can't expect the same ratio. The ratio that's true is the sine of an angle opposite its opposite side has to be the same in any triangle. But it's not the opposite angle divided by the opposite side, it's the sine of the opposite angle. So the only thing we know for sure is largest has to be opposite largest, and smallest has to be opposite smallest, and the medium angle has to be opposite the medium side. So that's the only test that really we can apply as a ballpark test.
Yeah.
All right, what else?
That's it actually.
Oh.
That was like all the questions that I had.
Have you come up against the ambiguous case of the law of sines?
Oh yeah, should we do that one, the one with like angle side triangles where you could have two possibilities?
Here's the perfect one. This is the textbook case. In other words, this problem would be given to you as angle A equals 30 degrees, side A equals 8, and side C equals 10. So there are the three pieces of information they've given you. Now the question is solve the triangle. So let's solve this triangle. What do we get? It's the first step. We can use the law of sines because we have an angle and we have its opposite side.
So we could do...
solve for angle C.
Okay, so sine C over 10 equals sine 30 over 8.
Okay. So what's the sine of C equal to?
.166.
Okay, at least we're less than 1. I don't think that's right though.
No, that's not right.
Because I know the sine of 30 is 1/2. So we're multiplying 1/2 by 10 over 8.
0.625.
Okay, now here's the critical step in dealing with the ambiguous case of the law of sines. What is angle C equal to?
38.
What's the other possible angle that C could be equal to? In other words, remember sine is positive in the first and second quadrant. So the supplementary angle to 38 degrees is also a possible solution. What's the...
So that would be 141.
I'm rounding off everything, 142.
Yeah.
Okay, so now the question is a 142 degree angle possible for angle C?
Yeah.
It is, because if we add it to 30, we're still less than 180. So the other picture for this triangle would be this. And notice everything that we were given is still the same. That's 10, that's 8, that angle's 30 degrees. This triangle fits those three conditions just like the big triangle does. Okay, only in this triangle, this angle C is 142 degrees. This one's 30. That leaves that little angle to be 8 degrees.
Yeah.
So here's my two different solutions. That's why it's called the ambiguous case of the law of sines. Now, if I took my supplement, in other words, I came up with 38 degrees and 142 degrees, right? If I add 142 to the only known angle, 30, and I get more than 180, then this second solution is not possible, and I would discard it. You know what I'm saying?
Yeah.
In other words, if I add this supplementary angle to the only angle I know, and I get more than 180, then I cross that out. It's not a solution. This is not a solution. But if it comes to less than 180, then both are solutions. And I have to allow for both of them. Okay, so now I have two different pictures here and two different problems I have to solve. This one is 38. What's angle B in my first triangle?
Angle B is 112.
What's angle B in my second triangle? 8. I've already labeled it. Still A, B, C. So now I've got 5 pieces of each triangle. The only thing I need is side B of the first one. What's side B going to be?
C over sine 112 equals 8 over sine 30.
Yeah. And the reason I write it like this is I always want my unknown to be in the numerator. It just makes the math easier. It makes doing the arithmetic easier. As opposed to saying sine of 112 over b, then I have a couple of extra steps of arithmetic to do. So as long as I put my unknown in the numerator, now I can just multiply both sides by sine of 112. What's that number?
Hold on. It's 14.8.
That passed the ballpark test for that triangle? And the only ballpark test you really need to apply is make sure that the longest side is opposite the largest angle. And the smallest side is opposite the smallest angle, and the other medium angle is opposite the medium side. So this does pass the ballpark test. Okay, so I'm going to go with this as one solution. Now let's solve this triangle over here. I still have to solve for side B. So I have side B over
Side B over sine 8 equals 8 over sine 30.
Yeah. So now come up with that number. 8 sine 8 times sine 30, or divided by sine 30.
It's 2.22.
So in this triangle, it's that picture. Does that pass the smell test?
Yeah.
It does. So those are two solutions. And notice that both solutions have exactly the same 3 initial conditions. And what you're always looking for here is where you have a side-side angle. In other words, when you're given side-side angle, you always have to be wary of 2 possible solutions. You never have to worry about it if it's Side, angle, side. You never have to worry about it if it's angle, side, angle. Anything other than side, side, angle is never going to be ambiguous. Furthermore, when you have side, side, angle, it's only potentially ambiguous if that angle is less than 90 degrees. If that angle is greater than 90 degrees, you don't have to worry about it.
Yeah.
And in fact, the smaller this angle is, the more likely it is to be ambiguous. In other words, if I make that a 80-degree angle instead of 30, not nearly as likely to be ambiguous.
Yeah.
Also, this side here has to be smaller than that side there. So there's some things you can look for potential ambiguity. But the easiest way to really do it is to just go ahead and apply the law of sines and calculate that first angle and calculate its supplementary angle also. In other words, once I solve for 38 degrees, the key is to make sure, okay, remember the sine is positive in both the first and the second quadrant. So the sine of 38 degrees happens to be equal to the sine of 142 degrees. And that's why the law of sines works in both of these triangles. Has to. This is the second quadrant angle that's equivalent to 38 degrees. So both of these things are going to produce exactly the same number with the same plus or minus sign.
Yeah.
And that's why that even when you're done here, it might look like this contradicts the law of sines, but it really doesn't, because the sine of 38 is the same as the sine of 142.
Yeah.
All right. So that's a perfect case. That's the kind of the classic case of the ambiguous case of the law of sines.
Yeah. All right.
I'm trying to think of other problems. I can't think of any other. Like I said, the only other difficult situation is where you have something like this. If I gave you those three conditions, and you went to solve this triangle, the first thing you're going to end up with is you're going to get the sine of C is some number greater than 1.
Yeah.
That tells you that it's an impossible triangle. In other words, this triangle I've drawn can't exist. There's no way I can have a side of 100 opposite a 30-degree angle and a side of 10 opposite whatever that angle is. I know that that can't be. Okay? And what's going to happen, let's go ahead and just quickly, we got 3 minutes, let's try to solve this triangle. So I would have the sine of C over 10 has to be equal to the sine of 30 over 100. So sine of C is going to be 10. What's 10? Sine of 30 divided by 100, that is 0.05.
Yeah. That's a possible triangle.
It is a possible triangle. I didn't make my numbers up properly. What did I do wrong?
Yeah.
I thought I was making an example that is not a possible triangle, but it looks like it is.
It would just make that side B really like 104 or something like that.
No, that's going to work also. If I make that 1,000, what am I doing wrong here? Sine of C divided by 10 equals sine of 30 divided by 1,000.
That would just make it 0.005.
Yeah, that would still be possible. I'm not sure what's going on here. I made this up out of my head, and obviously I made a mistake. But if you get the sine of an angle is some number outside the range of what sine can be, sine has to be between -1 and 1, always. It's impossible for the sine of some angle to be 1.1. That cannot be.
Yeah.
Okay, so if you are using the law of sines and you come up with the sine of an angle is equal to 1.1, you immediately know that you do not have a possible triangle.
What if it's the 10 and the 1,000 were switched? I think that might work.
I'm sorry, what?
If the 10 and the 1,000 were switched, I think
you're right. It would work, or even the 10 and the 100.
Yeah.
I'm not sure why. In other words, that gives you a number greater than 1. It gives you 5. And the sine of C cannot be equal to 5. So when I go to solve for C, your calculator is if you put inverse sine of 5 in your calculator, it's going to cough. It's going to tell you impossible, go to, bad function, whatever. Because there's no such thing as the inverse sine of 5.
Yeah.
All right. Those are the only difficult situations for the law of sines, is when you have the ambiguous case and when you have a triangle that can't be. That's it. Everything else is relatively easy when you're dealing with the law of sines.
All right.
All right. Lucas, I will talk to you next week.
All right. Talk to you then.
I apologize for being a few minutes late today. I'll be on time next week. Bye-bye.